On this week's MetPy Monday, we're going to go back to talking about functions. We're going to talk some about documenting functions, how you can do it, why you should do it, and how it can help future you or other users of your functions know exactly what they do and how to use them. Welcome to another MetPy Monday. Hello, I'm John Lehman, a software engineer for Unidata. On this week's MetPy Monday, we're going to talk some about function docstrings. So documenting your functions helps future you, which is the most common user of the code that you write, or any other users that you may have of code that you write, to know how to use your functions, what to expect in return, and other helpful things about it. Maybe what paper this formula came from, or an example of how to use the function, or maybe even the actual formula itself typeset. It's also following a practice called empathy-driven development, where unlike maybe driving with requirements or tests or other things, we're trying to use empathy to write our code so that we are nice to our future selves and our future users, and it's easy to use, easy to maintain, and we know it's accurate. Also, you should always remember when you're writing a function that I consider the docstring a mandatory part. Though it's not mandatory for the code to run, every function needs a docstring, and you need to update that docstring every time that you touch the function if you've changed anything about the inputs, outputs, or core functionality. So without any further ado, let's write a little bit of code. First, I'm going to import NumPy, and we're going to write a function to calculate wind speed from the U and V wind components. So U being the easterly component, V being the northerly component. So the wind speed, or the vector magnitude, is simply the square root of the sum of the squares of U and V. So this is a pretty simple calculation. So if you were writing this on your own, you might say something like this. Def wind speed, so we're defining the function. Wind speed is the thing it returns, so that's what we're going to call it. And it's going to take parameters U and V. And then we can return the square root of U squared, so U times U, plus V times V. Notice putting a space around all the operators following the PEP guidelines so it's nice and easy to read, though again, not necessary. So now we've run that, and I'm going to make some fake data here. So U is going to be mp.array, say 10, 15, 0, and 5. V, we're going to make that an array of 10, 8, 3, and 0. I forgot to do my import NumPy as np to give it that alias. Remember, programmers are lazy and we don't like typing a lot of long things, so we often do this, and importing NumPy as np is sort of the standard accepted convention. So now let's try out our function. Wind speed, U, V, and there we have our result. So that makes sense, but now let's say this function gets handed off to someone else. They don't know exactly what it's doing. Maybe they don't know what U and V are. They're not sure what it's returning. Does it take scalars? Does it take arrays? Does it take pandas data? Well, what does it take? And is there any other helpful information? So we need to write a docstring. Docstrings are enclosed in triple quotes. And then we write a quick summary of what the function does. So compute the wind speed from U and V components. There are several different conventions on how to do this. I'm going to show you the convention we use inside MetPy and my preferred convention as well. We're going to list the parameters. So we use parameters and then underscores. The first parameter is U, And then this is the type of it. So in this case, it is an array-like, which in Python means that we are going to be able to pass scalars, floats, arrays, lists, anything that is array-like and has array operations. Then we go down a line and indent and describe exactly what this parameter is. So when component in the x, which is the east, west direction. Then we're going to do the same for v. V is also array-like. It is the when component in the y, or north-south direction. Now, give yourself good descriptions here. This is a pretty simple function, so our descriptions are pretty short. If you need a paragraph to describe something, do it. Granted, you might want to rethink how you're implementing this function. Maybe it's not the right implementation, but be as descriptive as you need to be. Characters are free, so it doesn't cost you anything to type more documentation, and again, you'll thank yourself for it. Then we're going to specify the returns. So we return the wind speed. It is also array-like. Its description is the vector magnitude speed of the wind. There are lots of other things that you can put here. There's C also if there are other functions that users should know about that are similar. One thing, we could put notes, and we could just put the formula. So wind speed equals square root of u squared plus v squared. So that tells our user looking at the documentation exactly what we're doing. They don't have to go digging around in our code. Now, of course, it runs just the same as it did. We didn't modify the code. But if I put my cursor inside the open close parentheses here and press Shift Tab, now you'll see that I get that doc string that I wrote. So this is really helpful if I'm way further down in my notebook or in my script, or I'm using something that I've imported. This gives me a one-glance look at exactly what I need to be giving this function and what I'm going to get back. So this is really useful. It gives this functionality for free. It will make yourself and future users very happy. So I encourage you to go out, and anytime you touch a function that you've previously written, go ahead and write a doc string for it. And every time you type the keyword def to write a function, make sure you hit the triple quotes and type something in. Even if you don't fill out all of the parameters and returns, just a 1 or 2 sentence description of what the function does goes a long way to helping your future self. Hope that you found this useful, and I'll see you on next week's MetPy Monday.